we will start, we call optical instruments. Okay, so optical instruments, which is the last part of this chapter. Okay. Now what is the natural optical instrument that we have, which is made by nature automatically? Any thought?
Water.
Pardon?
Water.
Water. Is that an
What?
instrument?
Yes. I mean, naturally it reflects and refracts.
That's a medium. That's not optical instrument. Instrument means which is made up of many different things, and it does certain functions. One of the nature optical instrument is our eye. We call human eye. Correct. Eye is basically nothing but an optical instrument. It contains the lens. Let's see what it does. So we have discussed in much detail in the class 10th. Okay, but here we will just give the few glimpse of that. Something like this it looks like. So if you see the top part, top region here, correct, this is the top region. We call this is a cornea. Now when the light rays are coming from here, correct, any kind of light rays which are coming, let's say like this, they get refracted first. 70 to 80% refraction happens at cornea itself. Cornea does the most of the convergence automatically, correct? Now once we go inside that, here if you will see, there is a something called, in this region there is some liquid is formed. We call aqueous humor. Aqueous humor is nothing but a liquid. Okay, so it's a jelly like liquid which comes inside, and further the light ray get refracted. And then here we have a fantastic our convex lens which is available, which is connected by the ciliary muscle both side. Correct. So this is our eye lens is there, eye lens, and then here we have the ciliary muscle. So first what I will do, I will draw the figure and then we will discuss the function of everything. This layer we call sclera. Inside this also we have the liquid filled. Now this liquid we call vitreous humor. Okay. Now here, this entire region from here till here, this entire region we call retina. Retina is nothing but a screen where the image will get formed. Then after that there are few things that we should be aware. We call a yellow dot. Then here we get basically like a optic nerve which goes to the brain. Here we have one we call blind spot. Correct. This is the basically optical like our eye looks like. Okay, in a brief manner. Now let's go from left to right and let's discuss. Can you please help us to explain what are the functions of each and every part? So cornea we discussed. Okay, aqueous humor we discussed. Eye lens is basically like a convex lens. It helps to converge. Okay, because we would like to find out the image like converge here like this. What is the function of ciliary muscle? Any thought? What is the function of ciliary muscle? Any thought? I am asking.
Adjusting the thickness of the lens.
Thickness of the lens. Okay, so because of that what happens? Why it want to adjust?
For different focuses.
Okay.
to adjust for different focuses to like different objects at different distances clearly.
Fantastic, fantastic. So it is like, just in brief, like if you see this is our lens, this is our eye. You will be aware of that the diameter of this is just a 2.5 centimeter. Just 2.5. That means our eyeball is actually 2.5 centimeter. Everything is happening inside that only. Now, whether you whether you keep whether you keep the object here, whether you keep the object here, whether you keep the object here doesn't matter. Okay. The distance of the object, that means the u can vary. U can vary. But V should always be forming at this distance. So V is a fixed. Correct? U is varying, but V is a fixed. How that is possible? How can we get the image at the fixed distance? Because we know in the lens 1 upon F is equal to 1 upon V minus 1 upon U. Isn't it? So if V is fixed, so that means 1 upon F plus 1 upon U is equal to 1 upon V. This quantity is fixed. This quantity is, if this is varying, then this also has to vary. Question is, how can we change the focal length of the lens? There should be some provision for that, and which the ciliary muscle does actually. Ciliary muscle, if this is your normal lens, correct, it can basically make this is thicker also, like this. It can make is this further thinner also, like this, by stretching, by compressing. So here it is like a force is getting applied, something like this. This is the function of, and this we call accommodation of our eye. This property we call accommodation of eye. That means our eye can accommodate accordingly, accommodate the focal length based on the object distance automatically. Okay, it shouldn't ask the Prime Minister permission to do that. Automatically it does. This process we call accommodation of the eye. Clear? Getting?
Yes, sir.
Correct. So this is the main purpose of the ciliary muscle. Okay. Now the next thing comes, why we need the vitreous humor. What is vitreous humor actually? And what is the use?
It's a medium.
Yeah, but why we need that? What is the function of this?
Just like based on the yeah refractive index of that should allow the image to be caught on the retina.
Okay, see, yeah, that is there, that anyway, like the refraction will happen inside that, but the main purpose is that our eyeball, the shape should be maintained. Correct? Suppose you take a, suppose you take, let's say, some sort of a plastic bag. Okay, you have the plastic bag. Plastic bag, you can wrap it and put it in this size also. But when you fill something inside water, it take a particular shape. So it maintains that shape. We want our eyeball to remain in the spherical position. If you take out this liquid from here, what can happen? This surface can stick to this. Then you will never get an image. We don't want to make that happen. So we need some sort of a liquid. We can't put a solid, otherwise the light will not be able to go. So we need a transparent medium. This is a transparent medium that maintains the shape, basically. Correct? That's the main reason. Next one is the retina. This is the retina we call. Retina is nothing but our screen where the image is getting formed. Now the next question is, what is the yellow dot? Any thought? What is the yellow dot? Any idea? In our eye, what is the meaning of yellow dot?
I'm not sure, sir. Hearing it for the first time.
Oh, okay. Yellow dot is just a small region which is a very sensitive part. Very sensitive. Sensitive meaning is, if the light falls here, you will get a very bright image. Very bright image. So and at any particular angle only. That's why whenever, let's say, you are seeing the TV or you are seeing some sort of this, sometimes at particular angle you see like you are getting a very bright image. What is happening? That means your light is actually converging at the yellow spot, so you will get a very bright image. It's a very sensitive part in our eye. Okay, so this is just for awareness. Okay, that why we have that, because the cells which are present, they are little bit more sensitive. That's the main reason. Correct. Now the next thing comes blind spot. Any thought? What is the meaning of blind spot?
The opposite of the yellow spot.
Yeah, so blind spot is
Yeah.
basically like as the name suggests, if the light falls here, you will not see anything. Like it's a very dim. Correct? So we say like it's not sensitive for the light. It's a not at all sensitive for light. If the light falls there, you will not get an image. That we call as the blind spot. Correct? Now optic nerve, we know that whatever the image that we are getting actually get converted in the form of electric signals. You get the electric signals, and those electric signals goes through the optical nerve. They go to our neurons in our brain, and finally it is matched with the computer. Okay, what is happening? What kind of image? Then the image overlap happens, and then we see the 3D object. So many things happens in a fraction of a second. Amazing, isn't it? That means our eye knows more science and math than we actually know, because our eye is actually doing all these calculations properly with perfection all the time, no delay. Isn't it such an amazing thing? Now, so this is what the little bit discussion about this. Little bit move on. What we would like to discuss, what is the range of our eye? Range meaning is what distance we can see. What is the minimum distance? What is the maximum distance? Any thought? What we call that?
Least distance of distinct vision.
Yeah, that is how much?
For adults, I think it's 25 centimeter.
Correct. So minimum we used also called LDDV, least distinct of distinct vision. It's a 25 centimeter for a normal human eye. Maximum is how much?
Infinity.
Infinity. So maximum range is the infinity, like till which any human can see. Fantastic. So this is the range. This is the minimum distance. This is the maximum distance. Correct. And sometimes we represent this LDDV by a capital D. Correct. Just to represent that. Now the next thing that we would like to understand, we call persistence of vision. Any thought? What is the meaning of persistence of vision? Any idea?
Not sure, sir.
So persistence meaning is like, let's say you saw some figure, okay, and you saw another figure. So let's say this is the photo 1 and photo 2. Correct? Suppose the question comes, do we need to see both these photos in some time interval so that we can remember, or we can distinguish that these are two photos, or that there is no limitation for the time? Persistence means that whenever the image that you are getting actually on the screen here, okay, this image actually remains on the screen for some time, and after that it vanishes. That signal actually is diminishes. Then you get a new image, because whenever you are watching a movie, continuously image is getting formed, na? 1 2 3 4 5 6, like with a full speed that is going on. So there should be some time interval, na? so that you can identify, yeah, now the picture, now the hero is actually going. How do we know actually? If you see all those pictures, the movies, they are also the picture. Only thing is like their speed is more than the speed which our eye can detect. So scientists try to figure that out and how much it is. Okay. Our eye, our eye has the persistence only for 1 by 10 second. That means 0.1 second. So if you are watching a photo number 1, the image of this will remain in your brain or will remain in your screen for 0.1 second. Okay, let's say you saw one image and you kept your eye closed. Still it will be there 0.1 second. During that 0.1 second, if you see the second image also, you will not be able to recognize that you have seen the two photos. You will say, I have seen only one photo. This is called persistence. That means in order to see the two different photos, there should be a time lag of 0.1 second minimum. Maximum can be anything. This we call is the persistence of vision. Clear? Getting?
Yes, sir.
Now the next thing comes, we call binocular vision. Any thought on that? Binocular vision.
They're used like small devices used for viewing certain things from a far distance.
Okay. This binocular is not like a telescope or microscope. We are not discussing about that. Then we call binocular vision. That means we have two eyes. One eye, two eye. Question comes, why we have the two eyes? Why not one? How the two eye help us? Any thought on that? Why we have two eyes? What is the advantage of having two eyes? Any idea?
In case one stops working, the other like still remains. Or like if any one of them is harmed, one of them still remains.
Okay, so redundancy is the only, that is called a redundancy. Like if one is gone, other is there. Is that the only reason like God has given us two eyes or something else? That is
Uh,
fine. Any other thought? So there are mainly two reasons are there. The first is your field. If you have only one eye, you can only see 150-degree angle. Only 150. Because of two eyes, you can actually see. Okay, you can actually see approximately 180-degree. That means your field of view, this is called a field of view, has increased. Will that helpful? Yes, it is helpful. You can actually, so it is helpful so that you can catch your prey. You can, like animals can catch their prey. You can walk easily. You can recognize who is actually coming from back. 150-degree, that means your this side, if something is coming, you can't see. Something is coming, can't see. It's a 180-degree field of view increased. Second thing is that because of this binocular two eyes, we can see the 3D objects. 3D objects. If you have only one eye, you can't see 3D. Close your eyes. One eye you close, correct, completely, and then just you will start seeing only the one-dimensional. Two-dimensional basically. Depth you will not get. What happens here? See, the image is getting generated in this also. So what happens actually? Let's say this is your eye. This is the one eye, another eye. Here also we have the retina. Here also we have the retina. Here also we have the optical nerve. Here also we have the optical nerve. Let's say you are seeing a ball. From here also the light rays are going. From here also the light rays are going. Here we are getting the image number 1, image number 2. correct? But what happens actually, they are measured at a different angles. This is the alpha, this is the beta. Let's see. So what your mind does actually, your mind overlaps these two images. Image number 1, correct? And the image number 2, like this. And then try to create a depth because of this. So this depth which is coming because of these two images. If we cut off this image, correct, we will never get a depth. We cannot analyze that how far that object is, how far that person is sitting. It will look everything is like all the things are just at the same distance. That is called a binocular vision. Getting? It's a very interesting science. Okay. All your 3D films which are coming nowadays, 3D film, you put a glass, na? What that glass does, glass actually putting a, if you remove that glass, you observe like something is haziness, it is not clear. That is called the two-dimensional. That happens if you see from one eye. Okay, but if you put the two eye, you are basically putting that hologram. Okay, you are creating that third dimension, depth. Clear? So binocular vision does the two things: increase the field of view and enable us to see the 3D object. These are the two main reasons. Clear? Getting? Any doubt?
No, sir, no doubt.
Fantastic. Now the next thing comes, we call the resolving power of our eye. Resolving power or resolving limit, anything you can say. Any idea? What is the meaning of resolution?
How clear we can distinctly see different images, I mean objects.
How clearly we can see different objects?
The ability of our eye to see clearly.
Okay. So let's take an example. Suppose this is the pillar. This is the pillar. This is a one more pillar is there. Correct. This is a one more pillar. And let's say you are here. You are here approximately, and let's say you are in a train going, and these are the two pillars that you see. Let's say they are approximately some 10 kilometer distance from you. Correct? The question is that how much can you, like, is there any requirement that they should be at some distance so that you can see them, or it is not required? So let's say these two are making, here is your eye, here is your eye, and you are seeing the images of this at this point. This is coming. Let's say this angle is theta. Okay. Now what we would like to understand is, okay, this is, we call the resolution power. Our eye resolution power is 1 by 60. Okay, so 1 divided by 60 degree. That means 1 minute. 1 minute. If the two objects are making less than 1 minute angle, our eye cannot detect that these are the two different objects. It is impossible for our eye. This is the limitation. We call
So, sir,
yes.
that means we'll be seeing this as one object.
Yes, we will see that as a one object if the angle is made less than 1 minute. Correct? So let's say, suppose, let's say this is the question: how much should be they far apart so that we can clearly see? We can do the calculation. We can write angle is equal to arc upon radius, na? D by 10 kilometer. So D will be how much? Theta into 10. So theta is how much? 1 by 60. 1 by 60 I'll convert into radian, pi by 180 into 10 into 1000. 10101010. So approximately this is 3.14. So 314 divided by 6 into 18, correct? So if we do that, approximately, we just want to get the some rough number to get the feel. Okay, so we will get, yeah, approximately 3, correct? Approximately 3 meter. That means they should be 3 meter apart minimum. If they are more, then we can easily see because they will make more angle. But if it is a less than 3 meter, your eye cannot detect them two separate objects. Your eye will say like this is the same. They are the same pillars. Correct? This we call is the resolving power. Our eye has 1 minute is the resolving power. Every instrument, every measuring instrument has certain limitation, certain minimum thing we call least count. This is the least count of our eye. Getting? Okay.
Yes, sir.
Now the next thing is, in our eyes we can get the defect also. So most of the defects you would have learnt in class 10th. We will just quickly defects in eye quickly brush up. So there are two defects mainly, the myopia and hypermetropia. Quickly, can you explain what are those? What is myopia?
Short-sightedness.
Yeah, but what happens in this?
Okay, so we can't see objects from a far distance clearly because the eyes are too thick. That is, the muscles are contracting more.
Fantastic. So the defect where the image is getting formed beforehand, because this has become a thick. If it has become a thick, it is converging beforehand, before to the retina itself. So we can't see the far objects. So far objects, there is a problem exists. Near object, no problem, correct? No problem. That's the meaning, correct? Now what is happening? So far point basically we cannot see. Then what is happening? Our far point is actually coming closer. Earlier we were able to see till infinity, but no. Now let's say we can only see up to certain distance. Okay, it can be anything. Let's say from here it is a x distance. Earlier it was infinity. That means his problem is there with our far point. So how to correct that? We will basically put a concave lens. Concave lens will diverge them little bit. So if I put a concave here, it will little bit diverge, and then finally it will converge and it will reach to the retina. That's the whole purpose. So concave it does.
So in myopia, does the image form before the retina or after the retina?
In the myopia,
Yeah, does the image form like behind the retina or in front of the retina?
in front of retina, because it has become thick, na? Isn't
Yes,
it?
sir. Yeah.
Because the lens has become a thick. That's why it is coming. That's why you would like to diverge the rays. So diverge and then converge, so it will reach here. If it becomes here, that means what is happening? You need to converge them more. We don't want to do that. So this is basically, we use the concave lens of suitable focal length for this. And here what is the focal length will be? It is the focal. So let's say a person can see, let's say up to x distance. Okay, and person wants to see infinity. This is the current situation, this is the desirable situation. What should we do? We should put a focal length f, or the lens, concave lens with a focal length of minus x. Simple. Minus means concave. So we will put a concave lens focal length of minus x. So what will happen? Whatever the image which the concave lens is forming here, correct? It will form exactly at the image x distance, and from where we can easily see. See, our main purpose is that infinity, you put a lens which creates the image of the infinity at a x. Because from x we can clearly see, we don't have any issue. Our only thing we need, from infinity somebody can bring it to the x. So you want to reach to your house, somebody leave you till tower, your tower. You can easily reach after that. Okay, the person need not to come to your home. Same thing. From infinity we want to reach x, and for which we use the concave lens. That's the only purpose. Okay. Now, next comes the hypermetropia. What is hypermetropia is? It is exactly the opposite. Here what is happening? You have this one, you have the lens, light rays are coming. Now this time they are actually going behind. So their converging power has reduced, basically. Converging power has reduced. That means it has become thin lens. So what you will do? You will actually put a convex. So it will slightly converge first, and then it will further converge, and you will get like this. Perfect image. That's how we will get. Now here we use the convex lens. We know that. Same thing we can do here. Person cannot see the distance. Here it is actually far object is not a problem. Far object, no problem. Near object, there is a problem. So what happened? That means the person, if this is the eye basically of the person, earlier the person was able to see from 25 centimeter till infinity. But now this 25 centimeter actually has increased to, let's say, 60 centimeter. Below this, before this, the person can't see, person can't read, person can't do anything. Correct? So what we want? We want that any object which is here, they should create the image at 60 centimeter. Because from 60 centimeter we can easily see, no issues. Only the intention of the lens should be to create an image at this distance. Correct? And that's what we will do. So when you go to the optician, they tell you by measurement in the machine that this is the focal length that you need, this is the lens that you need, this is the power. How they identify actually? So what they do? Let's say the person can't see before small d. Let's say this distance is a small d. This is the minimum distance. 60 is the minimum distance which the person can clearly see. Before that it can't see. Correct? And person wants to see which is at a capital D distance. It can be focal length, it can be any distance which is here. Let's say you would like to read at 25 centimeter, you want to do that. What is the focal length will come out to be? We can apply the lens formula and we will get small d capital D divided by small d minus capital D. Clear? Getting? These are the two defects that we discussed. Now the next thing is another thing we call presbyopia. Any thought what is this? I am asking.
It's a case involving both.
What? Say it again.
It's a case in which there's both farsightedness and nearsightedness, like issue, both hyper and myopia.
Correct. So it is like both defects we have together. Both defects. And you will see like generally this happens during the old age. Why this happens? Because your power of accommodation is reduced. Power of accommodation is reduced. And why power of accommodation reduced? Because your ciliary muscle is not working properly. Why the ciliary muscle is not working properly? Because it has become tired. Why it has become tired? Because you were watching so much TV. You were watching so much mobile. You were watching so much laptop. Correct? Or you were so much tensed. Anything. That's the reason. So because of this, your ciliary muscle got tired. Ciliary muscle got tired, and then your power of accommodation reduced. And by the time you become old, you start getting both the defects. So for this we call bifocal lens. Bifocal lens. Bifocal means you will have like this. Here they will divide like this. Okay. So something like this. Okay. This is how. So let's say that concave is on the top and convex on the bottom. So depending upon which side is the which issue is there, we will decide. Nowadays, if you go, there are we call progressive lens has started coming. Progressive lens. Progressive lenses. What are progressive lenses? Because in the normal lens, if you put, you will get a line. Okay, progressive lens means you will not get a line. It will look very smooth. Correct? It's a costly basically. It is for the rich people. It is basically for style. Few people are there, na? Oh my God! In the glass you got a line. Ah. So all nowadays lens cart and other people they are putting up with a very fancy lens, fancy glasses. Correct? This is the progressive lens. They works on presbyopia. Clear getting another. Okay. Another thing we call astigmatism. Any thought what is this?
Uh, the ciliary muscles don't work at all.
Ah.
I'm not sure for them.
So it is basically like if you see your spherical ball is there, no? Spherical ball. It is not perfect sphere. If you see, it is basically some sort of a oblong shape. Some sort of a oblong shape like this. Now what happens? If you see this has the certain axis. Okay, our eye has certain axis. Because the reflection and refraction happens along the interface, na? And we draw the normal and other things like that. Now what happened actually, if you see the card of your mom, okay, there are two kind of powers are given. One we call spherical power. So spherical meaning is, just now we have learned myopia or hypermetropia. Another we call cylindrical power. Cylindrical. Okay. So because of this cylindrical, if this cylindrical power you have got, that means your capability to identify horizontal lines and vertical lines simultaneously, correct, simultaneously has reduced. So at the same time you cannot identify clearly, okay, this is horizontal and this is vertical at the same time. If sometimes we lose that property, we lose that capability. Okay, why this happens? Because this is not perfect spherical. Your eyeball is not perfect spherical. It's an imperfect spherical nature. So it will become like a oblong. Like we have learned the circle, na? in the 11th, and then we learned the ellipse. Ellipse has one major axis, one minor axis. We start doing the major minor, but in the circle we don't talk about major minor because all are equal. So because of this imperfect shape, what happens? You get the different axis, so the refraction will vary accordingly. Clear? This kind of lens we call spherical lens. We can reduce this by called the cylindrical lens. So there are cylindrical lens comes in the market, and we put those also in the glass. So light is getting refracted. It is ensuring that it convert from this to this. Okay. Now this is whatever the natural eye we have discussed. What is eye? What are the defects and other things? Now we are ready to move to the artificial instrument. So the artificial, we will discuss both. First we will discuss the microscope, and then we will discuss the telescope. So let's talk about microscope first. What is microscope? Any thought? I'm asking.
Used to view very extremely small objects, such as tiny bacteria and all that cells.
Okay. So to see tiny objects. But why we want to see? Why we can't see from our eyes? What's the problem?
Our eyes don't have the kind of resolving power, I think.
Correct. So if you see like let's say this is the basically like this. Okay. If I ask, okay, what do you see inside the circle? You will say a dot, isn't it? But why? Because uh, the angle this entire object which is there inside the circle is making in our eye is less than resolving power, less than 1 minute. 1 minute. So our eye cannot detect that there are two differentiated. So what we do? We actually magnify this entire zone. Further we magnify. Let's say after magnifying, we are seeing something like this. Okay. Now we can clearly identify because the angle made by each one of them is more than 1 minute. So this basically we call magnifying effect. We would like to magnify here. We would like to increase the size. That's the intention. Correct? So that means sometimes microscope, the simple microscope we call magnifying glass also. So magnifying glass like you can get in 100 rupees from the normal store, and that is also a microscope. It's a simple microscope. So now question comes, how much we want to magnify. So what is magnification is nothing but in general we defined what is the visual angle with an instrument, how much it is making with an instrument, and visual angle when object is placed at LDDV. So this is basically the in general magnifying power of any microscope. Clear? Now we will discuss there are types of microscope. What are the types? Any thought?
Simple and compound.
Simple and compound. What is the difference?
Simple uses only one convex lens, whereas compound uses two.
Why we need two? Why one is not sufficient enough? What's the issue?
For further magnification.
Yeah, but we can put here the one lens only with a higher magnifying power. What's the issue?
Uh, the that kind of lens, I think like one single lens cannot magnify it enough for our eyes to resolve it.
Yeah, but why it cannot? For an example, suppose you need a 100 GB hard disk. So what you are saying, okay, 100 like I cannot get in the market, so I will get a 150 GB, another 50 GB. But the question is why we can't get total 100? Because we all manufacture that. We don't have that refractive index power lens. What is the issue? See, we should be very clear that if that is the limitation, why that is the limitation? Is that the limitation now? Maybe down the line we don't have that limitation. Technology is continuously evolving. So first we should understand, okay, as of now we can't do that, but maybe after 10 years, who knows? We get a better technology. Correct. So, see, these are the questions that when we see the telescope or any kind of thing comes in the mind. And we will see them, what is the logic behind that. Okay. So let's see the first. In order to understand this question, we will just draw how the simple microscope work. So we know that in the simple microscope we have the one convex lens, and where we want to put the object. What is the intention? Where we put the object?
Very close to the lens.
Very close to the lens, correct? So we would like to get an image enlarged or smaller.
Enlarged.
Enlarged. So that means we know that F and C will be here and F and C will also be here. In a convex lens, we have already learned that we only get the enlarged image. Okay, we get the enlarged image when the object is kept between focal length and optical center, isn't it? Then we get on the same side. So let's say I am putting here somewhere the object is. Now what will happen? We will create the image pattern. One ray will go like this and it will pass through focal like this. Another we can put like this. Okay. Now our eyes are here. Our eyes only see the refracted rays which are coming. So these are the two rays which are coming from this. Now what is our eye tendency? Our eye basically try to trace it back. When that eye try to trace it back, what we will see? This is the image getting formed. Let's say this distance is capital D. This distance is U. Correct? Now there are two possibilities. Okay, what are the two possibilities? The one possibility is when the image is like object is like this. Now, so generally the object we will get will always be the smaller, closer to the lens. But the image that we are getting is getting formed here. So now let's evaluate that. What will be the aim will be? Aim is nothing but in the convex lens, it is nothing but h dash divided by h. So height of the image by height of the object divided by v divided by u. We already know that. Correct? Now what is v? V is nothing but the distance of the object, distance of the image, and u is the distance of the object. Now let's give it a shot. So in the lens we already know that 1 upon f is equal to 1 upon v minus 1 upon u. So how much will be 1 upon u? 1 upon u will be 1 upon v minus 1 upon f. Just plug it here. So what we will get? V into 1 upon v minus 1 upon f. Multiply inside. What we will get? 1 minus v divided by f. Correct? Generally, in the case of this, we used to call this is capital D. And this is on the left hand side because the image is getting formed on the left hand side. So V will be how much? V will be nothing but minus D. Plug it here. So we got magnification power is nothing but a capital D by F. This is the magnification power or the magnification power of this lens. 1 plus D upon F. Is that clear? There, one more thing we should remember in this, we shouldn't use the sign. If you remember in this, we need to take the sign convention properly, but here sign convention we have already taken. So do not put the sign convention again. That's the meaning. Getting? Now, there is a one problem here with this. Can you tell me what is the problem? Like, do we actually want to see the image like this? What will happen?
It's a virtual image.
Yeah, it's a virtual image. So the problem here is the image is getting formed. So when you are continuously seeing, the image is getting at this distance. And this is the image you are going into the eye. What is our eye tendency is? See, our eye is not designed by the God to see the mobile, to see the laptop, to see the nearby object for longer time. Our eye is not designed for that by nature. Our eye is designed to see the nature beauty. Correct? And beauty is not just lying in our apartment. It lies too far. It lies in the sky, which is too far. It lies in the mountains, which are too far. It lies in the rivers, which are too far. It lies in the nature. Okay? Beauty, which are too far. That means our eyes are designed for the far distances. When we see the far distances, okay, even for hours we can keep seeing them, but we will not get tensed. We will be feeling relaxed. Okay, amazed. Why? Because our eye is designed. So what we want actually that whatever the image which are coming, see what is happening, this lens has created the image which is here. Now this image is actually at a some far near distance from the eye. What we want that in our eye, whatever is the rays are coming, they should come parallel rays. That means they should come from infinity, so that our eye feel relaxed. We call relaxed eye calculation. This is the stressed eye magnification. So if you keep watching using that microscope for a some very tiny object, let's say for 2 hours, you'll start getting the headache. We don't want to make that happen. Okay, because the researcher has to do continuously 8-hour work, 10-hour work. Currently, the people who are actually finding out the coronavirus vaccine, they are continuously watching this 20 hours. If you use this, correct, what will happen? Your eyes need to be taken out. They will be gone in a month. We can't do that. So that means we need to do something else. For that, we call relaxed eye format. What we do? We take a lens, okay, and we put at a distance u. Here we are getting like this, and then we are getting like this. One is getting like this, and this is basically getting formed at infinity. These are two parallel rays. When that is possible? Any thought when that is possible? when that is possible, that light ray is actually after the refraction becoming a parallel. Any thought when that is possible?
External medium is,
Pardon?
I think it's related to the refractive index of the external medium.
It is dependent upon where you place the object. If you place the object at focal length, if the object is at focal, you get the image at infinity. We have discussed that earlier. If the object is actually between this, you get on the left hand side, but it will be at a finite distance. Okay. Now what is going to happen if you have keep this? Now we would like to find out the magnification, okay, for this kind of setup. This is also a simple microscope, but this is for, we call the relaxed eye. Relaxed eye. So when our eye will see from here, okay, what the parallel rays are coming, so they will feel relaxed. You can work for 20 hours, no issues. So let's say this is the angle which is making, okay, which it is making from here. It is a, let's say, theta I, and here this will also be the theta I, no change. Let's say this is the image of object height h. So what we can write from here, how much will be the what do you call, okay, so we can basically apply the similar properties. So what we will write, h dash upon h, which is nothing but a m. We also know it's a v upon u for this. Now from here, if we calculate, what is the tan theta? Tan theta I will be what? H dash divided by minus v. I'm not writing as of now f or other things. We will write that later, no issues. So tan theta is nothing but a h dash upon v. H dash upon v, correct? I'm applying the tan here. This is a h dash, okay, and divided by v. Something image is getting, let's say the image is getting formed here, correct? This is the h dash and this is the v, correct? Can we do that? I am asking. We know that v will be the infinity, we know that, but we are evaluating. They will maintain the same angle. Angle will remain the same image, because this is like a parallel lines. So what has happened? Now we will do h dash. H dash we can write from here. How much will be h dash? It will be h times v into u, and minus v is already there. V and v cancel. So finally what we got? Minus h upon u. Correct? So tan theta is minus h upon u. Now what is u actually? So this is tan theta, because the theta is a very small. We are talking about microscope. So here the angle will be very small, less than a 5 degree. Because the object itself is a very small. We are talking about the size of a bacteria. It is not in kilometers. So angle made will be very small. So we can assume this is approximately theta I. Will be nothing but minus h upon u. Isn't it? Now we are ready to calculate the magnification. What is the magnification will be? Okay. So, and yeah, let's put an object also. So this is the object. Sorry, this is the object. Let's put for object tan theta naught. How much will be tan theta naught? Tan theta naught will be nothing but h upon f. Can we write like this? H upon d. Let's write a d first. D is the distance at which the object is kept. So how much we will get? This is also the small, so we can write theta naught. It is nothing but h upon d. Now what is the magnification power? Magnification is nothing but theta I image by object. Image is how much? Minus h upon u divided by h upon d. So what you got? You got d upon minus d upon u. Now I am putting a sign. What is u is actually? Where we have kept? U is equal to minus f. Plug it here. So how much we'll get? Minus d upon f. Clear? Sorry, plus d upon f. So what is the magnification power we got? Capital D divided by f. What is the meaning of this? It gives a very, very interesting. Okay. It tells us that, okay, what it is telling? It is telling that when you have stressed eye, then your magnification power in the macroscope, you will get a 1 plus d by f. But when you have the relaxed eye, you will get a magnification capital D by f. Which is more, which is less? What do you think? Which is more, which is less?
Stressed eye is more.
Stressed eye is more. Correct? Okay, so stressed eye is more. Stressed eye is more meaning is, that means this is the maximum. So I can say mx and this is the minimum. What is the meaning? In the simple lens or the simple microscope, maximum power minus minimum power is always 1. Maximum is just 1 more than that. Correct? Now, same thing. Here where we are keeping the object, we are keeping at a LDDV, least distant. Correct? But suppose if we keep the lens at a distance from the eye. Okay, so let's say this is the lens. Here, this is the distance we have kept, which is a distance, A. How much will be the magnification power? Lens is kept at a distance A from the eye. Remember, refraction is happening here. Finally, we only need to see that image and conclude something. So that means our eye lens also play a major role. It is not just this lens which is playing a major role. Otherwise, we would have seen from our eye itself. Why we need the another lens? Correct? That's the main reason. So in this case, suppose if you are keeping, what I'm saying is if lens is kept at a distance small a from the eye, then your M will become how much? This is at a stressed eye. We also call sometimes MD because at a distance D will be how much? It will become 1 plus capital D minus small a by f. That's the only difference. And M infinity, this is called an M infinity, equal 1 plus, sorry, no 1 plus, D minus a by f. That's the another. Clear? Only like we have subtracted the a because it is at a distance a. Clear? Getting?
Yes, sir.
Okay. Now we are ready to move to the compound microscope. But before moving to the compound microscope, the question comes that why we need the compound microscope. The reason is, you tell me here, the magnification power depends upon whom? It is responsible on whom? Magnification power is inversely proportional to focal length. If the focal length is more, then the magnification power is less. Focal length is less, magnification power is more. Correct? Focal length more meaning focal length less. So in order to increase this M, we need to decrease the F. How can we decrease the F? That means suppose this has the some focal length. this lens. This is the lens is there. This is the focal length. Now if we want to decrease further, what we should do? We should make further smaller. We should make further smaller. We should make further smaller, because then only your focal length is decreasing. Now to increase the aim, we need to decrease the radius as much as possible. Now we have the manufacturing limitation. Below that we cannot manufacture that kind of lens curvature. It is not possible. We don't have a technology to do that. We don't have so much machine which can do so smaller. Correct? So till magnification number 9, m is equal to 9, we use the simple microscope only. That means 9 times you have magnified. 9, 10 maximum. Correct? But if you want to further use that, you can't use just a one lens, because you need to use the very, very small radius lens which is not manufacturable. Then how will you use that? That's the problem. So what we use? At the time we divide. Okay. Some kind of magnification we will do by one lens, and another kind of magnification we will do by another lens. That's what we will divide. So this is what we do. And here we have the two kind of lenses. This is the one lens, and then here we have the another lens. This is how we are getting. Now in this case, remember these two lenses, they are actually kept inside a tube. This is the tube is there in which these two lenses are there. We can increase or decrease the distance between them. We have the flexibility to do that. Correct? So let's see what is happening. Here is the object, which is an object AB. This object is creating an image. So what is happening? After refraction, you are getting an image. So let's talk about this. The first lens we call is the objective lens, because it is near to object. And this we call is the eyepiece lens, because it is near to eye. That's the reason. So here will be the object, here will be the eye. So objective lens and eyepiece lens. Now if you talk about this lens, so all the rays are coming, they are actually making the image here. It's an inverted image. It's a real image actually. You can put the screen and can capture that. So let's say this is AB, you will get A dash, B dash. Now this image actually behave like an object for this. So what will happen? Again the ray will start going. So from here the one rays will be parallel. After refraction, it will pass through focal like this. And another rays basically will pass through this. Now if you join, okay, and here is our eye actually. This is our eye. We will see from other side of the lens. Now whatever I will do, I will try to trace them back. If you trace them back, what you will see? You will see actually they are forming some sort of image. Here. They can form here, 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 anywhere they can form. Correct? So this is the distance. So again we will put here. We should be very clear what we are talking about here, otherwise there is a lot of confusion. This is a distance of the object from this lens. We call U0. U0 means objective. UO, objective lens. Then we are getting the image. We call VO, image. Correct? Now this image is actually behaving like a UE, which is this object for the eyepiece lens, and this is basically we are getting, we call VE. We sometimes call capital D, or sometimes till infinity. It can be anywhere, d to infinity. D is nothing but this image at least you should get at the LDDV. Before that you get the image, you will not be able to see that. Okay, so d to infinity it should be there. Is this clear? Is this image clear? I'm asking.
Yes, sir.
Correct. Now the question comes here. Generally it is told that the objective lens focal length, which focal length should be more, objective lens or eyepiece lens? Who,
Objective.
whose focal length should be more?
The objective.
And why? Okay, what is our intention from the compound microscope? We would like to get enlarged image. Enlarged image, isn't it? Okay, let's do one by one. Let's write down what is the enlargement the objective lens is doing. So how much is the magnification because of this one, objective lens? Can you tell me how can we find that out? Objective lens magnification, M objective. How will we calculate? How much is the height, A dash B dash divided by AB. That's how we calculate, na? We can also calculate like V naught by U naught, isn't it? Are you getting? And this will be minus. We had to put a minus now because this is this side. So minus V naught upon U naught. This is the magnification by this lens, by objective lens. Now what is the magnification by this? M eyepiece lens. How we will calculate? Where is the object? Object is at UE, which is nothing but here. Okay. And then we are getting the image on the same side. When that is possible? There are two possibilities. Either the image, this A dash B dash is, so UE can be either focal length of eyepiece lens, then only it is possible, or UE is less than focal length, then only it is possible to get the erect image. It is erect on the same side we are getting. This is the object, same side we are getting. This is also B double dash, A double dash. Are you able to see that?
Yes, sir.
Correct. So now from here, if you do, what you are going to get? We will write. So generally, okay, if it is a focal length or if it is, so how can we write that? We will write it is nothing but A double dash B double dash divided by AB. What is A double dash B double dash will be? So it will be, let's say, capital D, which we don't know. It will be minus capital D because it is on left side. And AB will be how much? It's a V upon U, na, basically. And this is nothing but a UE, so it will also be minus UE. Minus minus cancel. Capital D divided by U. Right? Now what is capital D? Capital D basically is nothing but, we can write, we can convert this into the 1 upon V is equal to 1 upon U plus. So in this also there are two possibilities. One is a relaxed eye, one is a stressed eye. First let's calculate for stressed eye. So for the stressed eye, just now we have done, we get a 1 plus capital D upon Fe. If I convert this into the 1 upon V plus 1 upon U upon, if I apply this, 1 upon F is equal to 1 upon V minus 1 upon U. 1 upon U we have, and then we write in this format, we will get this. That means what is the total magnification for the stressed eye? Stressed eye. So magnification is happening 2 times total. will be how much? MO into ME. That is the magnification. And how much that will be? MD will be nothing but minus V0 upon U. Okay, I'll write in the next slide. MD will be nothing but minus V0 upon U0 1 plus capital D upon FE. We can also write this, we can convert into focal length. So we can write minus FO upon UO minus FO, all are objective. 1 plus D upon FE, no change. We can also write in terms of V and F. So V0 minus F0 divided by F0, and this will be minus, then bracket 1 plus D upon F. So this is for the stressed eye that we have done. Stressed eye. Next thing comes for the relaxed eye. Correct? What are the changes for the relaxed eye will be? Are you getting all these, no? What we are doing?
Yes, sir.
Yeah. Any doubt, please do ask. Relaxed eye is nothing but a M infinity we say, because the image, final image is getting formed at infinity. Everything remains same, only thing like this will become D upon Fe. That's it. D upon Fe. Remaining thing also we will write U0 upon U0 minus F0 D upon F minus V0 minus F0 divided by F0 D upon F. So this is for the relaxed eye. Clear? Now the next thing comes, what is the length of this tube? Sometimes they ask, okay, how much should be this length of the tube? Because creating a compound microscope is a very difficult task. It's a very costly affair. It's not easy. So again, for both the cases it will be different. If it is for the stressed eye, total will be how much? LD. We write V0 plus UE. That's what is there now. V0 plus UE. So how much will we get? V0 we can write U0 F0 divided by U0 minus F0 plus UE we know FED divided by FE plus D. Correct? It is the same thing here. I have just taken the LCM FE plus D. Now suppose if it is for the relaxed eye, then we will get L infinity, which will be V0. Instead of FE UE, you will get FE directly. That's the only difference. So you will get U0 F0 divided by U0 minus F0 plus F. Clear? Getting? One thing we should be very clear. Please do not use sign convention. Sign convention in this is not required. Just use the plus value, because we have already used the sign convention. This formula already contains them. Otherwise it will be minus into minus will become plus. Clear? Getting?
Yes, sir.
Now the next part is, if you put this, okay, L infinity here, let's say this L infinity in this, okay, we get a very interesting formula which will helpful for us to get many things. We will get L infinity minus F0 minus Fe into D divided by Fo into Fe. This is the magnification for a compound microscope. Because when you go in the market, they will specify that, okay, this is the focal length of objective lens, this is the focal length of eyepiece lens, this is the capital D, this is the L infinity. It is a fixed once it is manufactured, once the microscope is manufactured. Now suppose you would like to maximize this. This is the, see, we are more interested in the magnification power at infinity for the relaxed eye, that we are more interested in. So how can we maximize M infinity? What should we do? Any thought? What should we do in this case to get the maximum?
Have
And
smaller. Okay, wait, no. Have smaller focal length of objective and eyepiece.
so FO and FE both should be smaller as much as possible. Correct? Both should be for the maximum magnification. And we have already learned that magnification is nothing but magnification of objective into magnification of eyepiece. All the time. Now suppose in this, if I exchange both these lenses, will there be any change in power? I'm asking. Will the magnification power will change? If I interchanged the lenses, what do you think?
No.
By interchanging the lenses, you will see that the power is not changing. Why? Because they are just a multiplication. Whether you do 2:3 or 3:2, answer will be exactly same, no change. So no change because of this. Correct? Now the next thing which is there, another thing is the resolving power. We'll discuss for the eye. Do we have the resolving power for the microscope also? Answer is yes. We have. Resolving power is exactly the same thing. So if you have, let's say, these are the two rays are coming. This is the objective lens. This is the angle. So the question is basically, it is the minimum distance between the two lines at which they are just distinct. We call is the resolving limit or the resolving power. How do we calculate that? RP. RP is nothing but a 2 mu sine theta divided by lambda. So resolving power of the microscope depends upon whom? It depends upon the wavelength of the light. That's why they utilize basically little lesser wavelength, so your this resolving power increases. It depends upon refractive index, and that makes sense also, right? Because we are doing the refraction, so refractive index should come into picture. Next thing is basically the half angle of the cone. It's a half angle. Okay, I think I have drawn the wrongly. Then this should be the half angle. This is the theta. Okay, so it's a half angle of the cone of light. Correct? Now based on this, if you see, generally ordinary microscope, or the when we are talking about this kind of microscope, compound microscope, so ordinary compound microscope, they have approximately resolving power of 5000 angstrom. That means 5000 angstrom. It's a very, very small. That means 5 into 10 to the power minus 7 meter. That means if I put 0.34, so 0.005 millimeter. Oh my god, what is the thickness of your hair? Any thought? Thickness of your hair?
So around 0.01 millimeters.
Correct. It's approximately like a 60 to 70 microns. Correct. So 0.06, 0.05 in that range. 0.0. So 0.05, but here it is 1000 times smaller than that. 1000 times smaller than the one thickness of hair. You can actually see, you can resolve it. You can see what is happening from the microscope by ordinary microscope. But that is not sufficient enough if we would like to see the atom and other things. So for that we need the electron beam microscope. Electron beam. It also works on the same principle, but only the it's an electronic discharge, because of which, and its power is approximately 1 angstrom. Oh my god, that means 5,000 times stronger than the ordinary compound microscope. That's why electron beam microscope is ultra costly, and it has a very high resolving power. It's the latest technology currently. Clear? Getting?
Yes, sir.
Okay, fine. So I think let's pause here, because